Good day, everyone. I'm Jem Paul Reyes, and I'm here to show you the first part of our activity, which is assessment clustering. So we have here our Rapid Miner Studio. So first we will import our data. So import. So where is your data? Go to your My Computer, and then I'll go to the documents. This PC because my data set is located to my download, and then next, and then next again, next, and finish. And I will put my data set in data in local repository, then finish. So I'll go here to this design, able to design our uh, process activity. So we have here our data set. We just drag our data set in the process design, and we will connect our data set in the process result, and then we will going to run it. So as you can see, we have here 2000 example observation, and then we have here 8 regular attribute, which is ID, sex, marital status, age, education, income, occupation, and settlement size. So I just expanded it so you can see. And then the next thing we will do is we're going to use the operator, which is the select attribute. So we just drag our select attribute here, and then we're going to use the attribute filter type, which is subset, and then select attributes. So as you can see, we have here our attributes, our 8 attributes. So we will just get our 8 attributes, which is, the 7 attributes, which is age, education, income, marital status, occupation, settlement size, and sex. So we just enter this arrow and then apply. And then we use select attributes operator to select a subset of attributes. And this subset is specified by the attributes parameter. The original output port is connected to the input port of the second selected attribute operator, which is with it earlier, and then the only normalized attributes are selected, which is the 7 attribute that we select. So we just run our uh, so now we have here our 7 regular attributes for this activity. So the next thing we will do, we will use the operator normalize. So we use this normalize to use the scale value of this fit specify range, adjusting the value range in the very important when dealing with the attribute of different unit and scale. So won't do anything about our parameter. We will just run, and we will see there will be much different for our data set earlier and for when we were run our activity. So as you can see, we have now our negative. The sex attribute might change in different value. Earlier we have attributes one. We have value 1 and 0 for our sex, but now we have here our negative, and then decimal, and so on for our other attribute. So as you can see in our last viewing of our dataset before we normalize our dataset, this is the before attributes that we display, and then when we use our normalize operator, it become different in our dataset. So we have here our negatives and then the changes of our dataset.
Hi, I'm Jennifer Marquez, and to continue our model, we will proceed to clustering. So clustering models identify groups of similar records and label them accordingly. So with the use of clustering operator, the k-means, we will put 6 cluster for this data set. Let's run. We can see we have 6 clusters. Cluster 0 is 427 items. Cluster 1, 348 items. Cluster 2 is 465 items. Cluster 3 is 434 items. Cluster 4 is 156 items. And cluster 5, we have 170 items. Total of 2,000 items. We go to Centroid. We can see that we have 6 clusters. So cluster 0, most of them are low income young women from small city, and cluster 1 is most of them are young non-single women from mid or small city. And for cluster 2, we have high earning single man. And for cluster 3, we have single people and fairly average in all other aspects. For cluster 4, we have non-singles. We look non-singles with tendentially higher educations and fairly average in all other aspects. And for cluster 5, we have slightly older single men, fairly average in all other aspects. So let's proceed. Let's go back to the design perspective and let's use the performance operator. We will use the cluster distance and we will connect the clustering to perform clustering to clustering and cluster examine. Then let's run. So we can see all the average centroid. So we can see that in the cluster average, they are closer together except for cluster 5, and our Davis-Baldwin is negative 1327. For Davis-Baldwin, the lower the better. And we can see in the cluster 0, we have negative 1.812, cluster 1, negative 2.495, cluster 2 is negative 2.886, cluster 3, we have negative 2.980, cluster 4 is negative 3.696, and cluster 5, we have negative 0.730. That's all for my discussion. Thank you.